Hi, everybody. We are doing slopes today. Just a quick little review, and then we'll finish the other stuff in class. Hopefully, I know last year it was a COVID year, so I don't remember how much. Let's rewind. Last year was a COVID year, so I don't know how much time your Algebra 1 class spent on slopes. So hopefully, at least some of these words remind you of things or ring some bells, but if not, buckle up, and here we go. So just a refresh, remember slope is the constant rate of change that your line is going. So you have different kinds of slope, obviously that they are depicted here. If it's going in an upward manner from left to right, it would be positive. You have a positive slope. If it's going downward as you move left to right, it is negative. Now these are the tricky ones. If it's just a horizontal line, that's a slope of 0. It's not increasing or decreasing, it's staying the exact same. And if it's vertical, it's undefined. Undefined. I like to abbreviate that one with UND. You do you. But those are our 4 slopes: positive, negative, 0, and undefined. You can find slope in a few different ways. When you're given a graph, we use rise over run. How far up and down we go over how far left and right we go. So if you remember correctly, you want to find spots on your graph that go perfectly in a corner through one of our boxes on our graph, right? So they've labeled them for us here, which is nice. So you want to go rise over run. So we'll count here. How many up do I have to go and how many over to be? 1, 2, 3, 4. So my rise is 4. How far am I running? 1, 2, 3, 4, 5. So 4/5 would be our slope. You always want to check to see if it can be simplified. This cannot be simplified. So it would just be 4/5. What else can I say? You always check yourself. This line is positive, so we should have a positive slope, which we do. Okay, another one here. Again, they're nice and give us those points there. So we'll do our rise over run. Now, since I'm going down, it's negative, right? So 1, 2, 3. So I'm going to have a negative rise. I'm going downwards. And then I'm going to the right, how many? 1, 2, 3, 4, 5, 6. Negative 3 over 6. Now you want to ask yourself, can I reduce? And I hope you're thinking absolutely we can. Negative 3 over 6 does reduce to negative 1 over 2. So that would be our slope of this line here. Again, check yourself. My slope is going down as I move left to right, so it should be negative, which is what we have here. Counting on a graph is quite easy. If, let's say, you're just given ordered pairs, so 2 points that are on your line, you would use this slope formula. So copy that down. Remember, it's the change in y over the change in x. So you just take your y coordinates and subtract them, throw them over your change in x coordinates, and subtract. Step 1, when you're looking for the slope of line AB here, is label your ordered pairs. Remember, each ordered pair has an x and a y, right? So this would be my x1, y1, b would be my x2, y2. Remember, each one gets an x and a y, and now we simply just plug in. So if we follow our formula here, what did we label as y2? Well, we labeled that as negative 1. Now follow your formula, minus your y1, which was 5, all over your x. So your x2 is 6, minus your x1 of negative 2, and now we just simplify our way out of this. 1 minus 5 would be negative 6 over 6 minus a negative 2 is really like adding over 8. Again, ask yourself, can you reduce? And I hope you're thinking absolutely we can. 2 goes into both of those, so negative 3 over 4. That is your slope. Again, same process here, kids. we have x1, y1, x2, y2, plug in, and let's crunch this out. So we'll have your y2, 7 minus your y1 of -3 over your x2 of -6 minus -11. All right, let's simplify. 7 minus -3 is 10. 6 minus -11 is really like adding, so it's -6 plus 11 is 5. 10 over 5 is 2 over 1, or you could just write it as 2. Either of those is a great answer. We do have some special relationships. I think we all know parallel lines are lines that do not touch, but they don't touch because they have the same slope. Did you guys know that? They're increasing or decreasing at the same rate. That's why they never touch. Perpendicular lines have opposite reciprocal slopes. Have you guys heard of that? Opposite reciprocals. So opposite means one's plus, one's minus, as one's positive, one's negative. And reciprocal means you flip your fraction, like that. They do a little dance. So on this bottom part here, we want to find the negative reciprocals or opposite reciprocals of these slopes. So on number 1, I have a positive 3/4. So if I want the opposite of that, I'm going to have a negative. The reciprocal of 3/4 would be 4/3. Those guys are perpendicular slopes. Remember that 2 is really over 1, right? So now it's quite easy to find the opposite reciprocal of this. 2 over 1 is positive, so I want negative. If I flip that fraction, I'm going to get 1 over 2. -7 over 8, well, I'm going to take the opposite of a negative number, which is positive, so it's going to be positive. Now flip your fraction, 8 over 7. All right, 1 is really over 1. So if I take the opposite of a positive 1, it's negative. If I flip 1 over 1, it's still just 1 over 1 or -1. Either of those answers work. And then our last one for this video lesson, 0. What is the opposite reciprocal of a slope of 0? Well, it's kind of confusing, so I'm going to back up a bit here. So remember, this is our line that's 0, right, with the slope of 0. If I want to be perpendicular to that, meaning I'm making a right angle, it needs to be a vertical line. So these two slopes here are opposite reciprocals. So if I go back, the opposite reciprocal of 0 as a slope is undefined. Okay, kids, thanks for watching. We will pick up where we left off. And I see you next. Goodbye.